Hello everyone and welcome back to the Oxford MAT Livestream. My name's James, I'm the admissions coordinator for maths, and today on the MAT Livestream I thought it'd be nice to talk about anything except the MAT. We've been talking about the MAT for about 13 weeks and yesterday quite a lot of us sat the MAT, so I thought it'd be fun today to just talk about anything else. There's all this other maths that we could be talking about. I've got some ideas about what I'm going to do today. Also, would quite like to hear what chat wants to talk about today, apart from math as well. We've already had one request in chat for not talking about math in chat as well, which we can't control, but let's try and keep off dwelling about tests that we might or might not have taken yesterday. Also, if you're looking for more math facts, there is a 10-minute video of me speedrunning all of the questions, highly edited, of course, and it's cut down to about 10 minutes of answers to questions. And there's going to be a proper debrief video live stream next Thursday in this slot next week. I've added a week rather than doing it now. I've added a week because I figure that the day after Matt, everyone's tired and stressed, and let's think about it for a week first. Was the paper intentionally made harder or easier this year? Just asking. That's a question about Matt, not Matt Stream. No comment as well. I'd like to see the scores first before I comment on whether that was a hard or easy one anyway. Yeah, no, it's not. So someone's put the speedrun thing, Matt 2021 any percent. But it's not an any percent, it's 100%. I've got to do all of the questions. So it's actually like more than 100% because I've got to do more than the 5 questions you would do if you were taking them at. So it's not any percent. Any percent would be answer no questions, refuse to elaborate, leave. That would be how you any percent the Matt. The video is 10 minutes or less. It doesn't count. It's 10 minutes and 90 seconds. It doesn't count intro and outro. Actually doing the math is under 10 minutes. This is a professional standards thing now. Hi Anika. Shout outs to chat. How am I going to do shout outs to chat? Yeah, hi Peter. Hi Anonymous. Hi Zach. Somebody did the maths. Matt Doer. Lucy's here. George. And Lily and Rilo. I can see her here. And E says, what A levels did this year's Matt do? It's a good question. It's both very on theme for chat. Good stuff. And people have spotted. So there was a Discord that might have happened. Okay. Interesting. Right. Let's find out how people are doing. Is it 130%? Thank you, Connor, for doing the maths. Connor says and B said, oh look, and Rilo, you were also good at working out your percentages today. Look at this, 130%. Not any percent. Right, cool. Let's do the poll. This is not talking about Matt, look. This is just a poll about how your day's going. Remembering, of course, that the rest of the world is, hey, look at the 1 and 2 stars. It's always interesting to me as well. I'm always looking out for people who vote 1 star or 2 star. How's your day going? But also, it's interesting to me how the thing changes over time. Anyway, do we start? Yeah, okay. If you ask an admissions question, chat's going super fast, and it's not even on the screen right now. Chat's going super fast. If I don't answer your question live, then I'll come back to them after I'm not live. It's unlike other live streams where your question just disappears in chat, we keep the full log, and afterwards I go through and I answer questions that I've missed. Cool, right, oh my word. Molly would like a Maths Club episode next year. We're doing requests for Maths Club episodes. Have I missed anything else? I'm well, thanks. You all survived. Yeah, if you're here now, you survived. You survived the thing that we're not talking about. People are voting 3.4, and there's quite a big chunk of 1 star, 2 star votes in there as well. How can we get the math scores? So Oxford applicants get their math scores automatically in January, right at the end. Imperial and Warwick applicants, you can get your math score as part of their feedback process. Ooh, the vote's balancing out. Look at those 1 stars go. My word. Quarter of the audience not having a good day, I'd say. And sorry to hear that, you know. That's not what we want. Hopefully, I'm going to do just silly stuff and make a fool of myself, and hopefully that will balance stuff out, right? Okay, barely survived. Oh, yeah, so people are asking, did I join the Discord? Was it the real James? So here's what happened. Some people started an unofficial Discord. Yesterday, I had to join it to ask people not to post spoilers about Matt questions. So I had to go into Discord. I don't use Discord. I had to go into Discord and tell people to not post spoilers which is something I do once a year. Cool, right. Okay. Would you say many will have found the test? So reading people's comments, do people feel like, it feels a bit like people might have found this test difficult, let's say that. I think I'm happy saying that. From what people are saying in chat, it looks like people maybe found this test difficult. Yeah, okay. Connor says, why did you make maths so hard? Ben would like to talk about fluid dynamics. An anonymous person would like an offer, which, you know, you're anonymous, so it's not even bribery. It's not even like, how would I even do that? Okay, so I wanted to tell you about some fluid dynamics because, you know, fluid dynamics. People don't know, but I did my PhD, the bit that got me this doctor, there it is. I did my PhD in fluid dynamics, and I'd like to show you something cool from fourth year of my maths degree on fluid dynamics. I hope that's okay. That sounds like it's going to be really hard because nobody knows any fluid dynamics yet, and nobody's doing fourth year maths at the moment. But I know that. I'm going to try and explain a bit from fourth year fluid dynamics. Yeah, that was me in the Discord telling you not to post spoilers. Cool. Right, good. Okay. Fluid dynamics. Here's the fact that we're going to explore, and it's really difficult doing maths outreach stuff like this, talking about hard maths things, because there's already stuff out there on like YouTube or stuff on other people's maths YouTube channels or stuff that you might have seen before. So I'm going to talk about reversibility and the Stokes equations, which you might have already seen in some other YouTube video. Request to prove the Riemann hypothesis. And somebody called Goat forgot how to spell their name, which if your name is Goat, then I can spell your name. Okay, cool, right. Here's how fluid dynamics works. Really quick intro. Fluid dynamics is quite sort of 18th, 19th century. Lots of it works around Newton's second law, F equals ma. The difference being that the accelerations, we're talking about the accelerations of lots of little fluid particles. Maybe we've got some sort of setup where there's some stuff that's not made of fluids, like some walls or some rocks, but then everything else around is fluid. What colour am I going to do there? Let's go for this. Is that horrible or nice? That's alright. There's some fluid around here. And we would like to solve for what the velocity is. The velocity is quite tricky because velocity is a vector, right? It's got components to what the velocity is. We'd like to solve for that everywhere. We'd like to know what the velocity is at every different point, which is pretty difficult. That's a hard thing to want to do, right? Before I even write down any equations or write down any maths for what we're going to try and do about it, this is just quite a difficult problem because we're solving for what the velocity is at lots of different places. People have done maybe a little bit of fluids in physics. And Alex asks, did I study at Oxford? I did not study at Oxford. I just joined Oxford to do this job. Okay. So there is some equation. It's not super important what the equation is. It's basically just F equals ma, some forces and balancing accelerations to tell you how each little bit of fluid separately has some sort of Newton's second law, forces mass times acceleration. So it's not a super exciting equation. It goes really complicated because it's a weird thing to be solving for, all these different vectors in different places, working out what the vectors are for the velocity are in different places. The equation is really complicated. Let's try and write down some of it, I suppose. Where am I going with this? So it turns out that if you're really small, imagine things like tiny sort of bacteria or little cells, or if you're just sort of a really small animal or something. If you're really small, or if the fluid is really sticky, then it turns out that then the internal forces, so the internal forces of friction, are much bigger. Those internal forces are much bigger than the accelerations. And that means the forces balance. Yeah, so I've assumed the mass is constant because I'm talking about one particular fluid particle, I suppose, but really I was just writing down F equals ma to balance that together. I studied at Cambridge. Cool. How long does it take to mark all the MAT papers, Mustafa asks? About a week and a half, maybe 2 weeks. I'm going to start doing some of them tomorrow evening, and then there's a team of about 100 graduate students marking them over a couple of weeks. Okay. So this is a sort of nice idea that it turns out that if your fluid is really sticky, there's lots of internal forces, these forces on a particular thing, and the accelerations are really small. You can imagine that being, if you're really small, there's not far to go, or if your fluid is very sticky, then you don't get to go very fast. So if your fluid is really small, if your things are really small, or your fluid is really sticky, or your velocity is really small, then you can kind of ignore the accelerations and just think about the forces balancing. The forces balancing is a really nice equation. If I was going to get some sort of maths tattoo, it would be the following maths tattoo. It's not going to mean very much, but the equation for force balance in these fluids is just lovely. It's this. And also you've got this kind of conservation of mass thing going on that I haven't mentioned yet, which is written like this. These equations that I'm writing out with these upside down triangles and all these dots and underlining and stuff. I know this doesn't mean anything to you, don't worry. This is some sort of notation for differential equations that you learn at university at some point that helps you write stuff with lots of different components, like how these have lots of different components, to write that very neatly. These symbols also turn up in things like Maxwell's laws in physics, where there's lots of different components of these vectors or different fields. Okay, so there's these really nice equations. The equations don't involve any time derivatives. What's a time derivative, I suppose? So a time derivative is like how velocity is the time derivative of position. You do dx by dt, and then acceleration is the time derivative of velocity. You do d by dt of the velocity. And sometimes equations like F equals ma, that's got a kind of time derivative of the velocity in there, in the acceleration. So my differential equation might depend on the velocities and have this time derivative of the velocities to tell me how the velocities change over time. But the equations for really small things, or really sticky fluids, don't have that time derivative in. That makes them really nice mathematically, because it means that we can solve them at a particular point in time, without worrying about the kind of history or the future of what the flow is. In particular, they've got some nice symmetries. This was all an excuse to talk about symmetry, really. Here's my little bit about symmetry. Okay. So here are some things, not expecting you to understand where these come from, but some nice symmetries. For, now these are called low Reynolds number fluids or something. So symmetries, what are we doing? Symmetries for these equations. I've got some nice symmetries. You can reflect your solution. So if you've got some solution for how a pebble might fall, there's a wall nearby, and maybe the pebble is going to fall over here somewhere and go this way, and you've worked out very carefully how all the fluid is going to go around that. So this is the pebble moving one way, but the wall stays still, and you've worked out how the fluid goes around. Then you can take your solution and look at it in a mirror. And if you look at it in the mirror, let's try and draw this properly, then the thing you get is also a solution. I think this makes sense because the real world is you can flip everything around and get the same laws of motion. I I think we do have Flora in chat today. Flora is helpfully approving chat messages and looking after chat. Thank you, Flora. Oh, there we go. There goes more stuff. Chat's going super fast. I'm really not keeping up with chat. Oh, Darishlay's here. Nice. Okay, so you can reflect. That one makes sense to me. That you can take your setup, predict what happens next, but also if you reflect everything, then you can work out what happens next. You can do translations as well. You can take your physics experiment, and if you take it upstairs or if you take it next door, you translate it, the same thing happens. Let's not think about reasons why it might or might not in the real world. Okay, the equations don't know about which way around you are, I suppose, where you are, and they don't know about reflections. Okay. Although I suppose taking it upstairs has reminded me about gravity. You've got to be careful, we're reflecting it, keeping gravity pointing down, I suppose. So we're keeping gravity, let's put it on a gravity arrow. There's gravity pointing down. I can't, if I take my pebble falling near a wall and I reflect it upwards, then that would be the solution if gravity was suddenly pointing upwards. Okay. So I can do different symmetries as well. Reflection kind of makes sense to me, but there's another one you can do where you reverse time, which sort of messes with people a bit, I think. Now, reversing time, the symmetry is a little bit different. You need to also reverse the forcing. So you also need to reverse the direction of gravity. So this says, if the direction of gravity reversed suddenly, then the pebble would go exactly the other way. And all the fluid around it would go exactly the other way if we reverse the forcing. Which is a pretty weird fact, right? I'm kind of taking a solution and multiplying everything by -1 to get a new solution to the differential equation. Which is something you can sometimes do. You can take something and multiply everything by -1 and get a new solution. But this one really messes with people because it means you can sort of reverse time and get a new solution. There's a demo on the internet where there's a demo on the internet where people take some really sticky fluid, like say some honey or something, and you draw a pattern in it. So maybe you've got a big tank of honey. There's now James describing an experiment. You know, what's the real world like? Mathematicians, I don't know. You take a big tank of honey. Here's my honey. You sign your name on the top, and then you stir it. You have maybe a stick in the middle. And you rotate that around so that your name that you've written on the top of the honey gets smeared out. You know, you can imagine turning that handle around so that it rotates. The honey all gets stretched and sheared apart. But then, if you rotate it back the other way, you can rotate back the other way, and the flow all reverses, and you end up back to where you started. So you write your name, you mess it up by rotating the middles a little, but then you can rotate back again and get back to where you started, which really messes with people as a guess of what might happen. Most physics is not really reversible like that. If you bake a cake, you can't then unbake it, probably. Anyway, normally that's where a YouTube video might stop or something. There's this cool experiment you can do. Yeah, the thing that Uwiki says, if you reverse it, you can return it to its original form. You can just run it back. One way to imagine this is like if you have a film of this happening. What do film cameras look like? Anyway, if you film this happening, I guess they've got like a spool, and then there's like a reed. Okay, if you film this happening and play it on a TV, what do TVs look like? That's dated to me, hasn't it? Nobody's TVs look like that since the 90s. Anyway, if you then rewind it, then you get another plausible video. Okay, gravity's the other way up, but it could be a story about a pebble where we filmed it maybe upside down and the gravity's pointing up. Okay. Should I bring my skateboard to the Oxford interview? Was a brilliant question that more people should ask this. There you go. Where's it? It's not. There it is. Should I bring my skateboard to the Oxford interview? Brilliant. That's my question of the day, I think. Cool. So normally this is presented as like a cool thing. I want to show you, and it is cool. I want to show you a maths thing you can do with this. Right. This is my aim. That's why I wanted to show you this on a maths live stream. We're going to do a little proof. We're going to prove that a sphere falling near a wall in viscous fluid, in what is this, really sticky fluid. What have I been calling it? Really sticky fluid. We're going to read that as like honey. Doesn't get closer to or further away from the wall. Sometimes my handwriting's so bad that I'd wonder why I bother writing the things that I'm saying out loud. Anyway, here's the facts. So, you've got a wall, you've got a sphere now, and you've got lots of honey around here. So maybe this is, I don't know. I like saying honey because honey's delicious. I sort of think there might be more money involved if you say oil every time instead of honey, but honey's more fun. Okay, so there's gravity pulling this down. And the fact is going to be that the sphere falls, but it doesn't get close to the wall and doesn't get further away. And let's have a quick think about intuition about why it might do one of those or the other. Why it might get closer to the wall. So it might feel like it gets closer to the wall because there's lots of sticky honey here that's kind of sticking it to the wall. So it might migrate towards the wall because it's kind of stuck. But on the other hand, there's loads of honey on the other side too that might want to slow it down, and maybe it wants to be free from the wall, where there's kind of the path of least resistance is to avoid this kind of immobile, sticky obstacle, to get away from it. So it's not obvious, when it falls, it's not obvious that it's going to fall straight down. Here's the proof. So suppose not. Suppose it falls at an angle like this. Suppose that's its velocity. Okay. So we can do a reflection. So I'm going to reflect it. I'm not going to do the left-right reflection that I did before. I'm going to do another reflection that works, which is to reflect like this in this line, I guess, in the midline. So this is going to be a story about a pebble that's falling surrounded by honey, but in a weird alternate universe where gravity points upwards. Okay, so this is another solution. There's something else that's plausible, and so far maybe this makes sense. It says if gravity's pulling it this way, then it migrates away. If gravity's pulling it that way, then it migrates away from the wall. But here comes the next killer blow, which is to say, well, then I'm going to film this and I'm going to reverse it. And what do I have then? Well, if I reverse it, then I'll get a little video that explains what happens under gravity, pointing down again, because we've reversed everything that's happening, reversed the forcing, reversed the velocity, and now we've got a pebble that's in the same place as it started. It's got gravity pulling it down, but now it's going towards the wall instead of away from the wall. And it can't do both. So this is a proof that if it was going to go away from the wall, then it would also go towards the wall. So here we go, contradiction. Can't do both. So straight down. Okay. I really like this proof. It uses those two symmetries together. So it uses a reflectional symmetry, and then it uses this time reversing symmetry to say, aha, if you're not straight down, then something weird's going on. Gravity's pulling it and it's going towards the wall and away from the wall. You can't have both of these, so it must be going straight down instead. Ooh, has Raphael found a video of this thing happening? Let's check that is a video of this happening and not some sort of... Yeah, that is a video of this happening and not some sort of rickroll. It's amazing. It's also... so this sequence of proof is something that I saw in my fourth year of my maths degree. And I really like it because it takes that kind of cool fact, this kind of cool physics engineering thing about reversing videos, link in chat now, thank you. And it shows how you can use that to prove things about what happens theoretically under solutions to this. It's also really easy to remember this proof because of that Missy Elliott song. You want to prove this, so you write the thing down, flip it and reverse it. And that's how I remember how to prove that spheres near walls don't migrate towards the wall or away from the wall. Write the thing down, flip it and reverse it. Okay, right, so was that an excuse for a bad pun or was that actual maths content? Who knows? Right, cool. Part of my aim is to go slightly further than what I've seen in YouTube videos as well. Cool, okay. Right, that was the punchline, by the way. Cool, right. What's next? These symmetries as well, talking about different things that you can do, they let you prove a lot of other things as well, so other nice setups about what happens when, for example, you've got a cube that's falling in a tank of honey. What happens to the cube? Does it spin as it falls? Does it tumble over? Or does it just translate straight down? What about if you've got a cone and you throw it in a tank of honey? Does it tend to go point down? And some other things as well, where you can argue using these symmetries without getting your hands wet. Right, cool. And people at the moment are doing like this message if you think you got more than 20 in MAT, and it's got more than 20 likes. Oh my word, that's more than 400 marks right there. Okay. What's next? Oh, okay. Oh, I've got a chat message telling me. Oh, there you go. Floria's here. Amazing stuff. Right, cool. This is totally planned and we're very on it today. Here we go. So I wanted to tell you about a different thing from my PhD. Goodbye, all of that. Excuse for a pun. I want to tell you a little bit about coordinates. Zach wants complex numbers. Oh, what have I got on complex numbers? Yeah, right. We'll do the dice thing next. I've got a dice thing. Okay. I've got a dice thing. The dice thing uses complex numbers, which is like, Zach wants it. It's got complex numbers. I think. And I'm saying I think because I had this idea for talking about dice on the MAT livestream at about 4:30 today, just before we started going live. So here's the plan. I'm going to tell you about a problem that I haven't really solved, and also I haven't really worked out what the problem is yet. So if you want to join in, then there are two jobs to do. We need to solve the problem, but also first we need to work out what the problem is. We need to work out what the right question is. People in chat excited about complex numbers. Right, cool. Okay. I'm just not quite sure what the right question is. Anyway, here's the setup. Here's what I'd like. Sometimes you're playing a game where you roll dice. Let's try and draw stuff. Today is also turning into a bit of an art stream, isn't it? There we go. Suppose you're playing a game where you roll stuff. Roll dice. Maybe you've got a 6-sided dice that could be 1, 2, 3, 4, 5, or 6. So you can roll the dice and you see what number you got. Sometimes in some sort of storytelling game, it's more fun if you don't know what the exact number that you got on the dice was. Maybe there's someone else like running the game. I'm thinking of Dungeons and Dragons. Cool, right, I'm going to stop pretending I'm not thinking of Dungeons and Dragons. Okay, I'm thinking of Dungeons and Dragons where there's somebody else monitoring the game who might be rolling some dice as well. They've also got dice. Right, cool. D&D, more dice. Okay. And the normal options when you're playing a game like this is either I can roll a die, and I can see what number I get, or this person with the screen hiding stuff can roll a secret dice. And there isn't really a way to split that up. There isn't really a way to roll 2 dice or something and add them together or something like that. That's not really a thing, because of course when you add dice together you get a different distribution of outcomes. So if I'm rolling dice, then if I want the outcome from the dice, but I want somewhere in between knowing what I rolled and not knowing at all what I rolled, then that's quite tricky. Where am I going with this? So I think I've worked out a way to do this, or at least sometimes a little bit. Maybe we should try and invent this a little bit. I'd like some sort of, here's what I want, some sort of roll, some sort of dice roll, then a secret dice roll, secretly added, so that I don't know what it is, so I don't really know what it is, what the total is, but I sort of know. Can you see what I meant about not quite knowing what the question is? I don't really know what the total is, but I sort of know what the total is. But I'd like that to be fair. I'd like the outcome to be like rolling a normal dice. Okay, with me so far? Here's something I've got. So what we could do is going to use different sizes of dice, I suppose. What we could do instead is I could roll some sort of mutant 3-sided dice. I don't really know what a 3-sided dice would look like. I suppose it would have 3 sides and one big side over here. Okay, cool. It would have 3 sides. My 3-sided dice would say 1, 3, 5 on it. Let's draw that differently. That's a terrible picture. Okay, so I would roll a dice that says 1, 3, 5. And okay, so I don't know what the total is yet, because secretly behind the screen the person running the game is going to roll a dice that just says 0 or 1. I guess that's like a coin flip thing going on. Okay, so I roll my 3-sided dice, and I get either 1, 3 or 5. They roll their 2-sided dice that says 0 or 1. I can't see that bit. But then the totals that you can get, they're kind of fair. It's equal probabilities for each of the numbers 1, 2, 3, 4, 5 and 6. Do you see what I mean? Yeah, so the 3-sided dice is a bit weird. People are pointing out problems with this. Mutant dice, Schrodinger's dice, a 3-sided dice with a very large curved face, perhaps. Yeah, that was maybe not my best dice design. You sometimes see these triangular prisms where you roll them and you have to hope that they don't balance on the ends. Maybe some sort of triangular prism with rounded bits on the ends to stop it balancing on the ends. This sort of does what I want. It's sort of what I was interested in. You know, I've got some dice rolling going on. They've got some secret adding dice roll, so that I sort of know what the total is, but there's a little bit of uncertainty, and overall it's fair. We get the numbers between 1 and 6. Could the 3-sided dice be a cylinder? Yeah, I like this. People are doing dice design, like a long coin. There's a Matt Parker video about 3-sided coins. If you make a coin thick enough, then there's some non-trivial probability that it lands on the curved side. How tall should you make the coin so that it lands on the curved side? It's a complicated question because of dice rolling is complicated. Half-sided, non-Euclidean, complicated, not really a normal shape. Yeah, so there's some problems with this thing I've invented, right? Doesn't quite feel very satisfying because I've got to roll a 3-sided dice. I reckon I can do that with a calculator or something nerdy like that. This coin flip seems alright. Also, now that we've seen it, it kind of feels a little bit obvious. I kind of want to explore other things that are a bit like this. Yeah, shout out to Matt Parker. Is the tetrahedron the simplest shape in three dimensions? Great question. Oh, yeah, let's do that instead. That's brilliant. I love this. I don't know what simplest means, but Maybe I do. So triangle is a simple shape, and they've pointed out that in 3D there's something called a tetrahedron, which means take a triangle. So 3D, take a triangle and join all the points to another point over here. So that gives you a tetrahedron. Okay. In 4D, you can take that tetrahedron and join all 4 points to some mysterious 5th point that lives somewhere else displaced in the 4th dimension. That gives you a 4-dimensional shape that's only got 5 corners, which is perhaps what you mean by simplest. And you can keep going. So in higher dimensions, you can keep making this shape where it's kind of got properties a bit like the tetrahedron and a bit like the triangle, where it's got, I suppose, n-1 corners, and each corner is joined to all the other corners by edges, and all the sets of 3 are faces. So yes, good question. You can keep going into higher dimensions. These are simple. These are called simplex. Well, each one is called a simplex. I think, pretty sure that's true. Ages since I learnt that. Might be completely wrong. Someone in chat says it's called an n-simplex. Brilliant, cool, I remember the right word. Good. Okay, we've got more suggestions. More suggestions for simple shapes in chat. Thank you, everyone. Right, cool. Other ways to factorize dice like this, and this does feel a little bit like factorizing. Okay, so other things we could do. I thought of other ways to make this work. Let's see if I can remember how they work. I think I can put a 1 and a 4 here, and then 0, 1, 2 over here, so that I end up with 1, 2, 3, 4, 5, 6 like this, which kind of feels different because the numbers are laid out in a different way. So then I maybe roll this one that just says 1 or 4, and the mutant weird 3-sided dice is hiding behind the screen. Let's go and roll to add some sort of modifier. Cool. People are way more interested in the simplest shapes than they are in my dice. I'm going to keep talking about dice anyway. So the way I got to complex numbers with this, and I promise there are some complex numbers coming, is that the one way to think about these probabilities, this thing that I want is for these probabilities to work out, one way to think about them is in terms of multiplying polynomials together. There's this rule which is amazing, that if you have some sort of dice, so maybe you've got one die and it's got some numbers on it. Let's go more general. If you've got something that takes discrete outputs, then you can make this polynomial where the coefficients, the exponents up here are the output numbers, and the numbers in the front, out the front, are supposed to be the probabilities that it lands on that one. So these are the probabilities, and these are the outcomes. Okay, so you can make this polynomial if it takes whole numbers that are coming out. Cool. Ooh, people got more suggestions. Oh look, so someone's engaging with this. 024 versus 1, 2 works as well. I think that's correct. Oh, I like this one. 1, 2, hang on, 1, 3, 4. Oh, I love this one. Does this work? That's amazing. 1, no, 2, 3. I can't count. 1, 2. Yeah, okay. I like this one. Good. It's not as weird as I thought it was because I can't add small numbers together. 1 plus 2 is 3. Welcome to the Oxford MAT Livestream. 0 plus 2. I got that one wrong as well. What is going on today? Cool. Oh, I like that one. Is it? Oh, right. Okay. You can make these polynomials. Right. Cool. Making polynomials like this. I learned this at some point in, I think, further maths. Anyway, the nice thing is that if this is like dice x, and you've also got dice y, then dice x plus y is the product. You just take the product of the polynomials. So you take the product of the polynomials. When you do the product of the polynomials, the coefficients that you multiply and add together give you exactly the right thing in terms of polynomials, exactly the right thing in terms of probabilities, so that the probability that this thing adds up to 6 is exactly, I suppose, the probability that this one's 5 plus the probability that y is 1. Probability that x is 5 times the probability that y is 1 plus the probability that x is 4 times the probability that y is 2, and so on. And that kind of pairs added together is exactly what you do when you multiply polynomials together. You find all the different pairs of coefficients that work, all the different pairs of powers that work, you multiply their coefficients together, and you add those things together. Cool. Ooh, that's loads of things. I like that. What's going on there? 222. This is a suggestion from Rilo in chat. Oh, is this going to be fair but involve lots of repetition? I'm going to do the addition now. I just got 0 plus 1 wrong. I think I might be too tired for MAT Livestream. Never mind. We're going to keep going. 2, 2, 2, 2, 2, 2. Yeah, this is going to work, isn't it? Oh, that's a lot of 5s. That's a lot of 5s. How can I fix this? I've got too many 5s and not enough 3s. I want some 3s. Not quite. I like the idea though. Having lots of things and then it turns out to be 1, 2, 3, 4, 5, 6 repeated lots of times. Cool. What actually is a polynomial? Yeah, so I think a polynomial is a sum of some powers of x with coefficients out the front. Maybe a better way to define polynomials would be 1 is a polynomial, x is a 1 is a polynomial. Yeah, okay. 1 is a polynomial. For any polynomial, x times p of x is a polynomial, and for any polynomial, k times p of x is also a polynomial. And do I need to close under addition as well? I'm not sure I do, but fine, whatever. Sums of polynomials are also polynomials. So you can kind of build them by defining. I probably want 0 to be a polynomial. Maybe that's in my k thing as well. You could probably define polynomials in terms of whether there is a polynomial, just the number 1 counts as a polynomial, and then whenever you multiply by x or a number or add things together, you still get a polynomial. And maybe that generates all of your polynomials together, rather than having to say something weird about exponents and sums and coefficients. But maybe that's a silly idea. Maybe people do just define polynomials like that. It doesn't really matter. I thought I'd say all of that so you've got an idea of some sort of definition that's defined kind of recursively, a bit like that definition of the set S from MAT 2020 last year. Yeah, right, cool. Someone's devastated. This is always the worst day, right? That I find out that lots of people are now very sad because of some MAT questions that I was involved in. It's one of the reasons I'm trying not to talk about MAT, I suppose. Okay, we got 15 minutes to try and get this to become about complex numbers. That feels like quite a long ask. Anyway, why am I telling you this? Okay, so these two mutant dice that we're trying to construct, the product of those polynomials should be exactly like one normal dice. We want these things to work out. So we want the product of the polynomials. We want this to be x to the 1 plus x squared plus x cubed plus x to the 4 plus x to the 5 plus x to the 6. With some multiplied by 1 over 6 or something. Times the whole thing for the equal probabilities on those numbers. We want this product to be this thing. So maybe we can make these. What's my other thing there? My other mutant dice was something like 1/2 of x to the 0 plus 1/2 of x to the 1. Maybe we can make these terms that I'm looking for, my kind of mutant half a dice. Maybe we can make these by factorizing this. Here's the weird fact. This has got lots of complex roots, I think. That when you go and factorize this, there are some complex roots, there are some complex numbers, and I think you need to engage with those in order to split this up into factors. This factorizes properly if you use complex numbers, because polynomials factorize over complex numbers. split this into complex number roots, and then merge them back together again, stick them back together again to build these factors, to find ways to factorize the kind of target polynomial, find ways to factorize it into these two mutant subbits. Each one behaves a little bit like half a dice, and it's only when you multiply them back together again that you get up to one full dice. That thing on the left is a bit like a sequence or like a recursion thing defining these polynomials. Cool, okay, so my plan for discovering these weird mutant half dice things is, well, we could keep guessing them, or we could try factorizing this polynomial and then combining the terms, combining it back together again. Along the way, things get a bit problematic because these polynomials I've just told you about, these ones that kind of beautifully represent a probability distribution that takes whole numbers, these polynomials are great. They do really nice things. They multiply together and that gives you the sum of the distributions. They're really nice, but it's not exactly every polynomial. If you've got negative numbers in your polynomial, in the coefficients, then I don't really know what a negative probability would mean. If some of your coefficients on your polynomial are really big, then I don't really know what a really big probability means, bigger than 1. These are called generating functions. Thank you, chat. I'd forgotten. These are called generating functions. So you can run into trouble when you do this factorizing, because you might get an interesting kind of mutant dice, but it's even worse than these things we've been considering because it's got some negative probabilities in it. And if you go too far and you factorize too much, then you get complex numbers in your polynomials. And then you're looking at something where it kind of corresponds to a weird mutant dice with 3 sides and complex number probabilities for rolling each of the sides, but I've no idea what that means. So this is kind of where I've got to with this. I think that factorizing this polynomial and then sticking it back together again might do something interesting. It might be a way to explain where things like this come from. I think that factorizing this polynomial might be the way in, but once you start factorizing this polynomial, you get scary stuff like negative numbers and complex numbers. So it's easy to get lost in the kind of maze of stuff going in there. SV says, aren't there negative probabilities when you calculate wave functions? That's not something I know about. That's not something I don't think so, but that stuff's really weird and I don't know very much about it. So, oh right, and Darishle said the same thing at the same time, which makes me think maybe there's something in there. Maybe there's something going on. Flora did simplicity. I missed your message again. Sorry, Flora. Flora was telling me good facts about simplices earlier. Simplicy is plural of simplex, like matrices is the plural of matrix. Flora was telling me about simplices in separately, but I missed your message, sorry. Cool. Right, I'm going to dress up as the Mat for Halloween next year, because that was absolutely terrifying. 2019, the Mat was on Halloween. It was on the 31st of October, extra spooky. So that'd be very efficient. You could dress up as the Mat immediately after taking it that year. It'll probably happen again one year in the future. We can all watch out for that. Things being cyclic like that, the way dates work. The user 7 would like to talk about dy by dx being a matrix. I think I did that last week. Should I do it again? Did people miss it last week? dy by dx is a little bit like a matrix. This is a sort of rant that I do sometimes, but I don't want to do the rants too often. I did the rant last week. I'm pretty sure I did the rant last week. Don't get me to repeat myself too much. Darishle wants to talk about complex derivatives, which is also yeah, right. There's a Mat question with werewolves and vampires. That's true. It's really hard. It's a really hard question and very spooky. Good. Who wrote question 2? I struggled with it, but once I figured out how to do it, it was quite beautiful. Question 2 is one of mine. I did question 2. is this true? I think it's the first long question I've ever written for math. I think that's true. Yeah, there we go. I'm going to stick with that. Question 2 is the first long question I've ever written for math. Sorry that you got the first one. Sorry, especially if you don't like logarithms. Cool. Rant about anything? Cool. No thumbs up, so. Are you going to do these in the future? Love these. Yeah. So this kind of mess. If you're interested in more mess, we're doing something called the Oxford Online Maths Club. What a segue. It's got more planning, and importantly, it's got guests on as well. We get guests like Flora and other current students involved to come on and talk about maths that they're interested in. This today is kind of like an imitation of that, except it's just me and I haven't prepared enough. So yeah, Oxford Online Maths Club is going to come back in January 2022. If you search for this phrase, then you should find it. I think there's a link on the Matt Live homepage as well, but that's going to be the new sort of live stream. Less maths, more random bits of maths with more current students. So less me going through this. Somebody likes question 2, that's nice. Trains Nerd wants to do some step questions. I've only got 10 minutes until 6. Do I stop at 6? Can't remember. Yeah, what does the derivative of a complex function even mean? What is a complex function? I think people are going into the complex functions. Flora is awesome, says someone in chat. There they are. Flora you're in at least one, maybe 2 Maths Club episodes. Previous episodes are available to stream. Flora came on and talked about topology. Ooh. Oh right, okay. Flora in separate chats has told me that her physics friends have said, I think this is scarier, probability amplitudes can be negative in quantum physics. Not the actual probabilities, the amplitudes, which I think is scarier. Yeah, Flora's in for topology and Penrose tiling, if you want to find those episodes. Cool, right. That's coming back in January with like actual qualified undergraduates, not just me rambling about derivatives. Let's do the derivative rant again. Okay. This time through the lens of complex numbers. Complex functions. It is going to bring us around full circle as well, so this is actually really good planning. Complex functions are in one of the episodes in season 2. Somewhere in season 2 there's a thing about complex functions. Here's a quick introduction to complex functions. Complex functions, when you first learn about them, are maybe a little bit disappointing. You use the same notation, like f of input. Maybe you write this. People tend to use these letters of the alphabet, but hey, here's my input, here's my output. But spooky, they are both complex numbers. Chat, it's what you've always wanted. Complex numbers on the live stream as the input and the output. Amazing. Wow. So something you'd like to be able to do is to just talk about the derivative. Like this. You'd like to set that function of z. Maybe the function of z is something like z squared plus 3z, and you'd like to work out the derivative to be 2z plus 3. That would be nice if you could do stuff like that. Yeah, I don't see why not. Just calculate your derivatives like that. Somebody's asked, what do they mean? Dressing up as a negative probability. Somebody's asked, what do these mean? And that's a really good question. It's actually quite hard to visualize these functions. You're quite good, maybe, if you've seen complex numbers, at imagining complex numbers as living in this 2D plane of where the complex numbers live. Maybe you've got this kind of Argand's diagram for where your input lives. But your outputs are also sort of living in an Argand diagram, because they've got real and imaginary parts as well. So this is like having an input number, maybe x plus iy, and an output number u plus iv, maybe, if I write down their real and imaginary parts. And there's loads of different functions going on here. U is sort of a function that depends on both x and y, and v is a function that depends on x and y as well. So we've got to imagine these different functions. Some people some people use these really nice ways of drawing what the function looks like by drawing the Argand diagram for z, the input, and then colouring in the points using different colours depending on what the output is. So if I use red over here, that means that the input here is in the kind of red bit of the output space to kind of pair things up, which is a bit of a strange idea maybe, but you get these kind of nice rainbows of saying, aha, the value over here is in the orange bit of W's Argand diagram. Yeah, you kind of you want a 4-dimensional graph. That's the thing that I'm not doing. Space. I haven't got space for a 4D graph. Good. If you've got these functions u and v, there are lots of different derivatives that you could work out. You could work out the derivative du dx. You can think about how u changes when you change the input variable x. So if this is something like x plus 3y or something, then you can think about how it changes when you change x. Oh, that just changes like x changes. You can think about how u changes when you change y. You can think about how v changes when you change x and how v changes when you change y. I'm doing these weird curly d's for derivatives. I'm hoping that you just think that it's my terrible handwriting. This is actually the notation for it. It's complicated. Let's not talk about it now. You can work out all these different derivatives, thinking about how does u change when I change x? How does u change when I change y? How does v change when I change x? How does v change when I change y? There's all these different derivatives you could work out. A sensible place to put all of them is in a matrix. And people who've heard my matrix inverse rant before know that if you want to find the inverse function, if you want to find derivatives of the inverse function, then you need to invert the matrix. So in the 1-dimensional analog is to just have a 1-by-1 matrix and invert it just by turning the thing upside down, because that's how you invert 1-by-1 matrices. Why am I writing D in a funny way? It's because it's because I mean something quite special. I mean, how does u change when I change x, but keeping y not changed? Which is slightly different to the thing that we've been doing in school or college, right? Where you just have one input variable, so it's clear what you mean when you change stuff. Here, these are called partial derivatives because they're just part of the picture, that I'm just differentiating, just changing x. Forget about y for a minute. It is one of the input variables, but forget about y, just change x. So these are actually doing something slightly different to the derivatives you learn in school. If it's a function of one variable, doesn't matter. Anyway, okay. What am I doing? Well, this says that bad news, if you've got these functions of two variables, then really your derivative is awful. It's not a function of two, it's not just a function of two variables, it's a 2-by-2 matrix. There's loads of these different derivatives that I could work out. And that's a bit sad because in the real world with real numbers, when I work out the derivative, it's just a real number, and that means something. It means something with the gradient, right? I just get a real number. You don't go and try and work out the derivative and it comes back, oh, that's some horrible massive matrix full of complex numbers. No. You work out the derivative, you get a real number. For functions of two variables like this, I've got two functions of two variables, functions from complex numbers to complex numbers. The derivative, it could be this horrible matrix of things. There's something nice going on though. Sometimes, for some special functions, there's something nice going on where this derivative sometimes behaves like a complex number. Now, how can a derivative, how can this matrix behave like a complex number? What would that mean? Here's what I mean. In this world where I've got these derivatives changing with x and y, the numbers that I'm putting in, these complex numbers, they're a bit like vectors. They've got a real part and an imaginary part. That's what we've been thinking about by drawing these pictures and thinking about these numbers coming in as real and imaginary things. So what I would do to work out the derivative, so I change in some direction. So as I change in some direction, I'd work out this matrix times a vector for the change in that direction. I guess this measures if you start at a point and if you walk in some direction, what's the change as you go in that direction. And you can multiply this matrix out, and this is horrible and a mess. This is not what I want. This is nothing like a complex number yet. Yeah, cool. Okay, this is some sort of vector, which is awful, but if du by dx is equal to dv by dy, we'll call it c, and if dv by dx is equal to minus du by dy, we'll call it d. If those things are true, if these things match up like this, then I'll get ac plus b. What do I want here? Du by, this is ac minus bd up here, and I'll get ad plus bc down here, dv by dy. And that's exactly what I would have got if I'd done a plus bi multiplied by c plus di. It's exactly like taking this original complex number that I was representing with a vector, and I multiplied it by a horrendous matrix. But sometimes, if these two equations are true, if these things match up, then it wasn't really like multiplying by a matrix at all. It was like multiplying by this complex number, c plus di, because the components work out to be exactly what they should be when you take the real and imaginary parts of a product of complex numbers. That's brilliant. If that happens, then I don't have to think about all this matrix multiplication and partial derivatives and all the horrible curly d's and everything going on, because my derivative is just a complex number. It's exactly what I want it to be. So it's like how when you do the derivative of a real function, you get a real number. Here, if these things are true, then you've got the derivative of a complex function would just be a complex number, which would be lovely. These have got a name. These are called the Cauchy-Riemann equations. And functions that satisfy this are called analytic, I think. And they're really nice. They have loads of nice properties, loads of nice things happen as a result of these derivatives working like complex numbers. Cauchy-Riemann. Yeah, I think I even spelled Riemann correctly. You can't tell because of the handwriting. Loads of nice things follow on from this. If you study this at university, this will be the first sort of things that you learn in complex analysis, which is like analysing complex functions. But an important property that your complex function might have is it might satisfy these equations, be analytic. Cool. Is it holomorphic instead? Am I wrong? Cool, let's go holomorphic and just let's hope that it doesn't matter, right? Cool. Right. Okay. I think I'm going to wrap up there. I did a little bit of rant. I did a little bit of how matrices. What did we do? We did derivatives are a bit like matrices, but then good news, sometimes the matrices are a bit like complex numbers. Isn't that everything that chat wanted? I think that's everything that chat wanted. Cool, right. Okay, I'm going to call it there, I think. I saw some questions. I'm going to answer a few questions quickly. I think there's some debate about holomorphic versus analytic. I'm not wrong. I'm not wrong. Yes, Flora. We're going to hide it down there so that if I was wrong, nobody will ever know. Cool, right. I think I'm going to ask some stuff. I am right. Lily's off. Is there no general chat? Let's do some general chat. Let's do a bit. Did I see the fact of the day? I missed the fact of the day. What have I missed in chat? Chat was going so fast earlier, and then I scared them all off by talking about dice. It's just us now. Right, just chatting. Let's go. Yeah, okay. Ooh, yeah, so the top comment at the moment is like this message if you think. Let's put top on. We never do this. Current top chat is like this message if you think you've got more than 20 in the mat. So this is now up to 1,000 marks because 50 people have got more than 20. Inequalities, more than 1,000 here. Look, it's the person pretending to be Grant Sanderson. Do not worry if you feel that you did poorly in maths. Right, okay. Internationally acclaimed celebrity. Great to have you here. Albert Einstein was born on Pi Day. Great fact. Thank you, Trains Nerd. Great fact, if true. It sounds true, doesn't it? It just, it just sort of makes sense. I'm fact checking you. Oh yeah, Albert Einstein was born on Pi Day. What a great fact. Like this message if you did the math, and there's fewer people. So, pigeonhole principle. Some people didn't do the math and got 20 marks. Worst 2.5 hours of my life. Emoji. 22 thumbs ups. Yeah, that's what I know about Gen Z. Molly's got some helpful stuff. Molly would like it if we didn't do this bit. Oh look, complex numbers. Zach, that actually won. We then did some complex numbers. Can I prove that Oxford is better than Cambridge? How's this proof going to work? Cambridge has got more letters, which is scary, right? And Oxford's got these zeros in it, which are really scary for when you're doing this inequality, because normally you want to show that something's bigger than 0. So this is scary to me because it's fewer things, and some of them are 0. So I'm going to have to hope that maybe some of these letters are negative. Now, I can see an I, so I'm hoping that I get another I, and this turns out to be a negative number. I can't see the I yet. Okay, where else am I going to come in? So there's an E on the end over here, which is good because that's about 2.7, so I know how big that is. And then, maybe this B is actually, another I in disguise. Maybe B is some constant that's equal to I times 1 over E, that then cancels this out and makes this negative, so that the right hand side is less than 0 on the left hand side. Cool, okay, yes I can. Good, test is harder. Going to dress up as the mat. Oh, it's jumping around a bit. Euclid's on fire today. Good, cool. What's going on in Just Chatting? What have I missed recently? Yeah. You can't do inequalities on complex numbers, so it's just, got to get lucky there. And make sure, have to assume it's true. AMGM, good inequality fact, everyone. I did the Timur. Is Timur online now? Welcome to Just Chatting. Somebody says I did the Timur and it disconnected 5 times. I see that this is weird to me because the MAT is a paper test, so you can't disconnect as much as maybe you want to. You did the Timur and it disconnected 5 times. Oh, okay. Is it? I didn't know it was online. Maybe. Yeah. Anyway. Pigeonhole principle, somebody mentioned that with the username 1+1. Welcome to the MAT livestream. This is user 1+1. Somebody mentioned the pigeonhole principle. I've remembered that there was an Oxford Online Maths Club episode about that as well. Christian was on in episode about, I want to say 4, maybe 3 or 4. Episode 3 or 4. And the BMAT had some problems. I've heard about BMAT's problems. The BMAT just completely went wrong in some test centres, which would be pretty bad. Right. I should scroll this up so that chat's on screen. Cool. What did I score in? When do we find out? Let's do some starred stuff. The starred stuff's ages ago. Fraser wanted to know, when do we find out if we have interviews? I would say, more than 3 weeks. Yeah, more like 4 weeks, I think. 4 weeks from now, end of November or early December. I think we're sending letters out. Don't quote me on this, don't hassle people, but I think 29th of November is when we're planning to send out the maths letters. Different subjects, different dates. So BMAT crashing was then maybe disruptive for other people. So BMAT I think is done on computers, and I don't know exactly what went wrong, but I've heard reports that they couldn't do the BMATs in some centres. Euclid says thanks for your feistiness, which I have not felt very feisty today. Anyway, what time of the day are the interviews? Is there a latest time in the day when they can be? So the interviews normally run throughout the day. I think we've done interviews at 6 PM before. I think I might have had an interview at 6 PM. We don't want to do them too late because we've got other stuff as well. Somebody says they did worse in the maths than they could have done, which I'm sorry to hear that. Is that bad? Well, if your score's still a good score, then it's probably not that bad. But we are using the MAT to compare applicants against each other to decide who to shortlist. Everyone in my school started screaming. Yeah, so BMAT, because it's for medics as well, so in my experience, the people applying for medicine, the people studying medicine at university are incredibly clever and really good at lots of stuff. And they want to spend their careers helping people, so also nice people. You can't even fault them for that. And yeah, if the BMAT's not going well, then that's a stressful experience for some really nice, hard-working people. When do the famous histograms get released? The famous histogram gets put on the... Yeah, the histogram gets released in January. I'm trying to remember when I do things. Histogram comes out in January. I think I put a sneak preview in the MAT livestream last year. So if you're watching the show, then there might be a sneak preview of a histogram. Because once I've marked... I don't know how it's going to work. Histogram's in January. Unless there's a sneak preview. Good. Okay. I was expecting to have a nice exam. I was scoring 90s. Yeah, people normally do better in the past papers than they do in the actual exam. I don't really know what that is, other than sort of exam stress. I mean, I can guess. I'm usually worried. Yeah, there we go. Handwriting. Working on even and multiple choice questions are messed up. Yeah, I always felt that I made more mistakes in the actual exam. When I did STEP exams, so I did STEP instead of MATs because I applied to different universities. When I did STEP, I thought I'd done a lot of past papers, I thought I'd done quite well in past papers, and then I did the actual test and I thought it was horrible. And I thought I'd done really badly and wasn't going to get to go to the universities I wanted to. And then it turned out I'd done okay, and it was just a really hard test. I got an okay grade, and I got to go to the universities I wanted to. Universities, plural. I got to go to the university one I wanted to. Book recommendations for learning about proof. How to Solve It is the classic book about proof. I also quite like, what's it called? Forgotten what it's called. Learning about proofs is quite specific. If you haven't read Vicky Neal's Closing the Gap, then you might like Vicky Neal's Closing the Gap. It's a story about some people proving a thing. It's a story about research maths. It's also got lots of hooks, lots of bits in there for you to think, I could try that, try working that out. So there's sort of, it's not all about cutting edge research maths. There's also bits in there for you to think about and join in with. Closing the Gap. Fraser, applying from outside the UK. I think it's all email. We're doing all the interviews online. We've got to work out how these computer things work. So I think we're doing emails for everything. I'm hoping it's emails and not post. As far as I know, they're sent out by the different colleges. And as far as I know, everyone's using email. Pesky computers. What are they good for? Hoping to get 9 out of 10. So solutions for the multiple choice are in that 10-minute video that I put up this morning that I'm trying not to think about too much. I think I said last week, I would not watch the 10-minute video. I don't want to see the solutions straight after doing a test. It's out there if you want to find out how you did in the multiple choice questions. How much do we get penalised for silly mistakes like arithmetic errors? Not very much. We give marks for method. So if you've had the right ideas, if you've got good working out that shows, this is why I get people to write working out, right? If you've got good working out that shows what you were trying to do and what your idea was, then we can give you marks for your method, usually. It's tricky. If the question tells you, you can get multiple methods. That's a good general thing to say. Messed up multiple choice really crest. Sorry to hear that, Rishley. The average on the multiple choice questions is, what is the average? Over the last, I looked at this once, if you look at the last 10 years, I've got the data set, so in the last 10 years, and you look at the average on the multiple choice questions, I think it's 6. I think it's about 6 out of 10 for the average on those, which kind of makes sense when you think about the overall score, but 6 out of 10 is, well, it's slightly more than half. It's not 10 out of 10, right? So then when sort of highly motivated people who are doing lots of past papers and stuff, feel like you can give this test where you get 6 out of 10. It still feels really different to every other test you do. And I guess we're finding that out now for live. By the way, all the people saying last week that they've never done a real exam because GCSEs were cancelled, and maybe you would be worried about A-levels coming up in summer. Well, hey, you've now done a big stressful exam. You've got one out of the way. So that's one thing we got out of this, I suppose. Lily, I am once again asking, so it's the Bernie meme, I am once again asking you for an Xmas Mat live episode. Is this like, Lily, what's the plan? Is it like Christmas Day? I tell all my sorry everyone, Christmas Day, leave the cake, leave the presents. I need to go and talk about triangles on the internet. Is that a plan? Is that what we're asking for? I'm wearing the hat, maybe? Like the paper crown, and then after the maths, I'm like, okay, that was great. The Queen's speech comes on, and that's a very strange ask. At least ask for Boxing Day, right? Someone said they solved Matt in the shower, which sounds clever, but then I realised they meant the shower afterwards. Tamur used the same system as BMAT. Special considerations. This is the thing. So special considerations. If something was disrupting your math experience yesterday, or if something happened, or if you had a panic attack, or if there was something that meant you didn't perform at your best, that can be reported. That can be reported by your test centre on something called a special considerations form. You need to get them to do that form. If you tell them about it, then you should be able to find the form on the exam entries extranet to do the special considerations form to report that on to us. Is there a chance you could get a different number of marks depending on who marks it? So hopefully not. I've written a lot of stuff. I've written a lot of information for the different people marking it, and they have to work together. So that if anything is controversial or tricky to mark, they talk to each other to make sure that they're being fair between different scripts. So I suppose when you've got multiple people marking, there's always a chance of this, but we're really trying to make sure we're consistent between different markers. Okay, good question. That's going to be the next 2 weeks of my life. The next 2 weeks of my life is going to be coordinating, making sure that doesn't happen. Right. I know Paulie, so many A-level exams. People have got A-level exams as well. So many other exams going on. If I bring my cat to the interview, can I bribe them? So that the interviews are all online this year. So it's a cat on a webcam, I guess. Just not quite how bribing works, but I do like cats. So I've confused people now. Here comes the question. Is the interview decision through the post? No, it's an email. It's an email. We've all got. It used to be, in sort of the olden days, used to be letters. It's an email these days, I'm sure. Okay. Small mistakes in real exams can relate. Very relatable. University Explorer. Am I really behind with chat? I'm 5 minutes behind with chat. Right. Do I know when BMIG results are released? No, I don't. Who thought of the triangle triple questions? That was submitted by the computer science department. Question 5 is almost always submitted by the computer science department. Please be nice to the computer science department. I think overall we'll look back on question 5 as a good question. I think. In the past post, I got most short questions. The actually, I'll cut the time at 20 minutes. I'm sure. I think it may have cost me. So Raf tried to speedrun the short questions, but maybe that's good. Who knows? Maybe if you spent 20 more minutes on the short questions, you wouldn't have got any more marks. Who knows? Maybe those 20 minutes were better spent thinking about long questions and getting marks. Who knows? Also, it's your life. You can make decisions. So it's allowed. Can you get email support from tutors? Euclid, you've asked a sensible question. I don't get it. Half the questions are very sensible and half the questions not. Or maybe it's 2 users. So the tutors, most tutors are, I guess, happy to take questions by email from the people they're giving tutorials to. I'm giving someone tutorials for different equations at the moment, and we're also having email chat about differential equations. It's nice. Our email chat about differential equations is, at the moment, she's found something that might be wrong with one of the questions on the sheet, and I'm trying to understand why it might be wrong, or understand why I don't think it's wrong. Just talking about differential equations. Fun. How nice are the people marking the questions? Here's the thing, the guidance I'm giving them is we are trying to be the sort of people marking tests that we would have wanted marking our tests when we were doing tests not that long ago. I'm old. The guidance is that we're trying to be nice. We're trying to, if you've had the idea, if you've written us anything that shows that you've had an idea about how to do the question, we want to give you a mark for it, usually. I don't want to think about the 10-minute video because I don't like thinking about exams that I've just done. I meant kind of if I just came out of the exam, I don't want to think about it. Start questions. Yeah, I know I've missed a load. Right. Area of trapezium wrong. Okay, there we go. Area of trapezium incorrectly. My first step. Method mark for trying. If we can tell that you were trying to work out the area of a trapezium, it's 1 mark. If you get the area of a trapezium correct, you got the 2nd mark. Thanks for this free. You see, it's the same Euclid who wanted to bring a skateboard to an interview. So now it's like, thank you for this free. Oh, it's just gives you a shake, right? Cool. Is it weird that I found 1J? I want to show this question. Right, we try to sort the questions, right? We try to put J as normally supposed to be one that we found quite hard. I'm with you. I think 1J is easier. But all the other people on the question panel who had a go at it thought that 1J was the hardest one. So we put it last. I'm gonna print this comment out. Like, oh, look, one kid agrees, or whoever, one person agrees with me. 1J. Lily wants tinsel and decorations and Xmas-y problems. Okay. Well, that's still a 5-minute chat lag. Right, speed up a bit. Year 8s for doing PE in that extreme. Sounds loud. Warwick and Imperial get the score. They can request the paper, I think. Can't remember. Tech for the interviews. You will get lots of communication and information if you get shortlisted. Maths is going to use technology like this. Whiteboards, writing, so you can see things, which you can get into through the internet. And if you've got something like a tablet for writing or a mouse, then you can join in. It's better with something like a tablet or a pointing thing rather than a mouse. If need be, we'll just write down what you're saying or something instead. Don't worry about the tech. Ooh, what's that flashing light mean on my screen? Anyway, cool. Heart rates, emails. Do I teach year 1 maths? No, so I do some tutorials. I do some small group teaching, but I wouldn't really say that I teach first year maths. Okay. BMorg. Oh, we released the day. That's fun. Predicted 3A stars, and you got loads of stuff. Does it make any difference where you get the marks? The first thing we look at is your overall mark. The first thing we look at. We can then look down at where you got the marks. It would be rare to look at where you got the marks within a part. Mostly we're comparing people on a bigger scale than that, I suppose. Favourite number of dimensions? 3. It's where I'm from. Would I ever reject an IMO person? That depends how good they are at math. Cool. Generous, very generous. Markers are selected. Grad students sign up. Molly's off. Bye, Molly. Chatty style format. Yeah, we're just doing other stuff now, aren't we? Maths, we completed it, mate. And now it's just chit chat. Thank you. Scores higher. Do I think scores? Oh, Oxford or Cambridge? Oh my word! Look at chat go. Religion. What is sine 30? I'm doing colleges for New College. I can't even remember what question I was getting out of answering by noticing a flashing light on my computer. Right, cool. Start questions. What college do you do tutorials for? New College. I just said that. When is my birthday? End of February. When's the end of February? Complicated research question. When is the end of February? When the statistics? Yeah, stats coming out. The averages come out. I think I'll do the averages mid-November. Mid-November, maybe. That's for the first one. I might do the second one. No, I think I'll do the other ones in January at the end. I get quite busy towards the end, so that's why there's a break. There's a gap in between where Lily wants a Christmas special. There's a gap in between the last MAT live stream in a couple of weeks and the start of Maths Club in January. There's a gap in there where I'm just like constantly organising interviews and helping people decide which offers we're going to make. Favourite step paper I've ever done? It's probably 2000 and... one of the old ones, like 2004 maybe? 2004 was one that we did in I used to help with something called Step Study School, where we got people from around the country and gave them some step help. It's one of the reasons I do this. Some step help. We used the questions from 2004 step, so I know those ones because we did the same questions every year and I got really good at them. I like 2004. I think 2007's another banger. Right, 5 minutes to midnight. Bye. Aris speaks to everyone for saying thank you, which is nice of you. Really good. State school. I'm looking at stars questions now. Accessing math scores. Yeah, okay. Sending scores to other universities. Questions about that. Don't worry about them now. Don't worry about them now. There are instructions on the MAT webpage. Durham and Bath, I'm hoping, will contact applicants to find out what's going on. Find out what your MAT registration numbers were to collect your MAT scores. I'm hoping they have some system for doing that. I don't want to rush before they've set up their system. What are you doing step papers? Why are you doing step papers? I did step papers because I applied to Cambridge. Can I talk about Jesus? One of the colleges is named after him. We do have a Jesus college, and we've got a Corpus Christi college, which is also named after Jesus. And we've got a Christ Church, which is named after Jesus' church. I think Cambridge have got at least 3 as well, because there's Christ's College, Corpus Christi, another one, and also Jesus College in Cambridge. So that's like 6 colleges, all called Jesus, really. And Trinity. That's like Trinity College in each of them that's like 1/3 Jesus as well. So that's another 2/3 overall. So 6 and 2/3 overall named after Jesus. Cool. How can we get UKMT scores to Oxford? See, we don't really need your UKMT or Olympiad scores because we can't really compare people, because not everyone's done the UKMT or Olympiad stuff. It sounds silly to say this the day after MAT, but it's one of the reasons we got you all to do the MAT, was that we've got this test that you've all done. You're encouraged, like after you've applied, you're encouraged to keep doing more math stuff, but you don't need to update us on it. We've got lots of information now already. Okay. Trinity College, all in capitals. Brilliant. Is there a cutoff for shortlisting? There's no hard cutoff on the map, but in terms of MAT school, there is a hard cutoff on date. There's a deadline. It's an internal deadline where we're all going to get our shortlisting decisions done. You don't need to worry about that. Cool. Yes, Trinity, there we go. 1/3 of Jesus. So 6 and 2/3, right? Cool. Yeah. Bless you. Right. Why is Cambridge? Yeah. Do you want to talk about rankings? Do you want the rankings rant? Why is Cambridge ranked higher than Oxford for maths? Firstly, says who? Secondly, depends what your ranking is, right? Cool. I think these things tell you more about the ranking than they tell you about the universities. Anyway, here's the full name of Jesus College. There you go. There's some content for you for chat from Soda. Thank you. The full name of Jesus College. Do Trinity next. The full name of Trinity College is a bit weird too, I think. College of the Blessed Virgin Mary, St John the Evangelist, and the Glorious Virgin St Radicand, near Cambridge. It's very much in Cambridge. If you're looking at the open day, and you're thinking, oh, that one's only near Cambridge. No, that one's in Cambridge. I guess one day it was nearish Cambridge. Cool. Having a UKMT senior challenge. Oh, particular advice to understand the process. UKMT challenges are different, aren't they? They're multiple choice. I think UKMT challenges are a little bit like MAT questions, or maybe it's the other way around. Maybe MAT questions are a little bit like UKMT challenge. Except UKMT uses, I think, less maths, even less stuff in there, because there's no calculus, is there? I sort of hope my secret ulterior motive, doing the MAT livestream, secret ulterior motive, is that by doing all this stuff, we're getting better at maths, and we're getting better at problem solving, so that when some other problems come along, even if they're not literally MAT problems, that we might be better equipped to try and solve them. That's like my secret. Don't tell everyone. Anyone here? Yeah, no one's here. Good. No one's here. Don't tell. I'm hoping that we got better at maths. Now, earlier today, I tried to add together 2 and 1, and I got the wrong answer. So it hasn't worked for me. I'm still terrible at maths, but maybe you've got better. Maybe my maths ability is like leached out into the live stream, and now I can't add together Norton 2, but maybe you can. Right, okay. Did you go to Trinity, James? Yeah, I went to Trinity College, Cambridge. It was great fun. I loved it. Right. Are we anonymous to those who mark the MAT papers? That's an important question. Yes. They don't know who you are. Number of O's. Do I like my job? Yeah, this job's great. This is probably the most stressful bit of the job, where math's actually happening and we've got to assess all the applicants. But for the rest of the year, when it's talking to people who are thinking about applying to university or thinking about going to university to do maths or just interested in maths, that's great. Right, I'm now recorded on camera. I like my job. How long do we get for the MAT? The MAT is a 2.5 hour exam. Do the colleges with Christian names accept only Christian students? No. Can you lose marks for wrong answers? I can't remember. Oh yeah, you can lose. There's a UKMT thing. It's to punish guessing. MAT doesn't do that. Oh yeah, other people are doing that. Yeah, Polar 2 question. Do you want to do the Polar 2 question? So Polar 2 is this postcode metric where it measures whether people in that postcode, whether lots of them go to university or not. It's sort of looking at across the country, what's the distribution of who's going to university. People in the southeast, people in London, lots of them are going to university. People elsewhere, it's different in different places. So Pillar 2 looks that up on a postcode level. Oxford uses this data. We get this information because it's interesting to us. If you've got a reasonably good maths score and you've got a sort of strongish application, it's interesting to us if that's from a region where not so many people go to university, I suppose. It's one of the things we look at. We look at some other ones as well. Polars, we've got some other ones. Polar's got some problems because the postcodes are a little bit. Postcodes are weird. We're not doing the postcode rant. Postcodes are weird, and that's one of the metrics. So yeah, it's something we've got data on. Something we're looking at. We combine a lot of these things together to look at an overall picture. You don't want to know the details, it's complicated. If I get into Oxford, can I come and see you and have a fun conversation? No, you can come and see me and have a boring conversation. Once you're here, no fun at all. Yeah, no, come and say hi. Right. Yeah, in particular, if anybody comes to Oxford, very keen for people to join in with a maths club. I've met the first years now. We stood up in front of all the first years and said, hi, do you want to come on the maths club? And some of them had seen the maths club, so I'm hoping that next term we get to meet people on the live stream who were doing MAT Livestream last year and did maths club maybe a little bit as well. What was my dream job growing up? What did I want to do when I was growing up? I can't even remember. It sort of doesn't. I had a plan, right? I had a plan, and the plan has really, really not happened. But yeah. No, I hate this. It's a terrible job. James or Flora, will you be marking any of the 2021 papers? So Flora's not marking, I think, because I'm using graduate students, and Flora's not a graduate student yet. And I'm in charge of the marking process for all of them. So I'm going to have access to all of them. Good. No negative marks. Yeah, no penalties, no punishments. Darn hard to get into Trinity Cambridge for maths. Clever with loads of R's. Right, okay. Oh, graphing things. Yeah, graphing things. Anika's off. Bye. I think we're wrapping up. Somebody wants to be a doctor. Oh, is there a Doctor Who society at Oxford? Great question. I can't imagine that there's not. There's quite a lot of societies. It's surprisingly easy to start a new society, and if somehow there wasn't already a Doctor Who society and you started one, then I think other people would join in. What are your events going to be? I guess you can do watch parties. You can watch Doctor Who together. This definitely already happens. You can watch Doctor Who together. You can dress up as different doctors. You can have arguments about which the best doctors are. You can go to Doctor Who experience things together. Oh, that'd be great fun. What a nice society. Please start it if it's not a thing. Whichever university, Oxford or not, I don't mind. Whichever university you're at, please start a Doctor Who society if there isn't one already. If your voice was a colour, what colour would it be? It's kind of weird brownish green, right? Like a weird mix of brown and green. Bye everyone. I don't know what the Belvita Society is. Isn't Belvita a sort of biscuit? Yeah, I think it's a sort of biscuit. Let me just check. Yes, it's a biscuit. Yeah, I know this biscuit. Okay, I know the biscuit, but I don't know the society. So, no idea. What percentage of applicants do you reckon have seen some of your live streams? We did a vote, not on live streams, but on Matt content, and it's about 50% or 80% of the people in the room, somewhere more than half, I think, of people in the room had seen some Matt's content, maybe just the 10-minute video. But we've definitely got first years at the moment who were sitting where you're sitting last year, watching Matt live stream stuff. Ta-da, live stream. Right, cool. Oh, blue voice over there. Oh, interesting. I have not thought about the colour of my voice before. If one does a PhD in Oxford, one is not permitted to be an Oxford professor. He is sent to Cambridge and vice versa. Is this true? No. That's definitely not true. No. Nah. That's also not what's happened here, by the way. Right, okay. I think on that. Oh, look, it's Isaac. Well, Isaac, the future founder of the Doctor Who Society at Oxford, Barrett, as everybody knows them. Right, okay. Somebody's got, what did you want to see when you grow up? I wanted to start the Doctor Who Society at Oxford, if they don't already have one. I think that seems like a nice point to wrap up on. There's the haircut question. No, I just have less hair each time because I'm getting old. Good. Interview decisions are coming out at the end of the month, and next week we're going to do a proper debrief and talk about MAT 2021. I want to talk about approximating pi. I want to talk about the return of Charlie to MAT questions. I want to talk about logarithms, because there are some logarithms in MAT, and a joke question that turned into a real question. So we'll do some of that in MAT Livestream next week. Thank you very much for watching. I've no idea why this video's got 63 likes, but maybe we're doing something right. Okay, have a nice evening. I'm going to answer some starter questions that I missed before. We'll see you next week for MAT Livestream, actual 2021 questions. If you don't want to see that, don't tune in next week. But yeah, see you then. How do I stop a live stream? I remember this button. Bye.